That will be recorded. Okay, so question 1. Sine -194. Write each of the following as trigonometric ratios of positive acute angles. An acute angle is an angle that lies between 0 and 90. So these are degrees, of course, between 0 and pi/2. Same thing. So if you are given sine -194, you've got several ways of getting back to the acute angle that is positive. We have the quadrants. Quadrant 1, 2, 3, and 4. In quadrant 1, all the trig ratios are positive. In quadrant 2, only sine and cosec are positive. In quadrant 3, only tan and cot are positive. In the fourth quadrant, only cos and sec are positive. Now what happens is that when they say an acute angles actually have another name that we use in quadrants. So we say they are reference angles to all the angles in other quadrants. Now, because all the acute angles give us a positive responses, it implies that if you use them as reference angles for some other angle, you must be careful with the sign that comes out. For example, 45 is in the first quadrant. There's an angle that gives us the exact value as 45 in the second quadrant. Now, if we get theta as a reference angle, if x, the x whose reference angle we're looking for, falls in the first quadrant, the reference angle theta will be the same x. But if you have an angle x, you're looking for a reference angle, but your x falls in the second quadrant, and you want to find its reference angle, you will say 180 minus that angle x. If your x falls in the third quadrant, and you want to find the theta, which is the reference angle of that x, then theta, the reference angle of x, will be x, the given angle, minus 180. If that given angle falls in the fourth quadrant, in the third quadrant. In the fourth quadrant, you say 360 minus x degrees. Remember, we have 0 up to 90, the angles in the first quadrant, and 90 up to 180, the angles in the second quadrant. 180 up to 270, the angles in the third quadrant. 270 up to 360, the angles in the fourth quadrant. That's the reason why we are saying, because all reference angles will be acute angles. All reference angles are acute angles. So for you to get that angle, it is by doing this in each quadrant. So you do that. This information here is very important. Okay, now we go back to our question. Find, write the trigonometric ratio as a positive, as the ratio of a positive acute angle. So if the angle given 1, if the angle given theta is less than 0, you keep, let me just say, you add you add 360 degrees until it becomes positive. Two, if the theta given is bigger than 360, you subtract 360 degrees from theta until it becomes less than 360. So what we are having in one, what we have in one is negative 194. 194 is less than 0. So we'll say negative 194 plus, because we are saying you add, plus 360. Now when we add, we'll get 166. 166, so now we are saying this guy is exactly the same as sine 166. Because when it's negative, you are starting from there going this way. So you reach somewhere here. That is negative 194. So when you add 360, it means that you've gone in reverse. So when you start from there, that angle there is 166. So these two angles are called coterminal angles. Coterminal angles have same properties in everything. So now the question says we must give the ratio in the positive acute angle. But what we have here is an obtuse angle. An obtuse angle is the angle that runs from 90 to 180. But we're asked to give an acute angle. So we need to look for the reference angle of 166. Now, where do we find 166? It is found in the second quadrant. So for us to go back in the first quadrant, we need to subtract from 180. Theta is equal to 180 minus 166. And there we get 14. So we want to deal with sine 14 degrees of cos. Now, sine is positive in the first quadrant. Sine is positive in the second quadrant. So sine 166 is exactly the same as sine 14. So it means that the required ratio is sine 14. Unless there are questions, question 1, part 1 is done. Okay, so since there are no questions, we move to part 2. How possible was that? I should have gone maybe for a second or 4. So as they're explaining this one, most of the concepts that were explained in one will come back. So 481 is bigger than 360. So what do? We subtract from 481, we subtract 360. And we'll get 1, 2, 1. So this guy is exactly the same as cos 121 degrees. Now 121 is in the second quadrant. So if you're in the second quadrant, how do you get a theta? You subtract. So we'll say, okay, the theta we want to use is 180 minus 121, which is going to be 9. So get 59. So now 59 is in the first quadrant, but in the first quadrant, cos is positive, and yet negative in the second quadrant. So to emphasize that we are presenting 121 with a reference angle, we are going to first start with a sign of cos in the second quadrant, which is negative. And then we can now bring the reference angle, which is 59. So we have left it as a ratio with an acute angle, positive acute angle. So that you guys at your own time can do 3 and 4. So nice.
Sir.
Hello.
I didn't get on how we added the negative to negative cos 59.
So it starts from here, from the quadrant. What is cos in the second quadrant? It is negative. And 121 lies in the second quadrant. But we have chosen, the question is actually forcing us to use an angle that lies in the first quadrant, where all the trig ratios are positive. But the angle we're dealing with is in the first quadrant. Is in the second quadrant. So to show that the angle we're dealing with in the second quadrant, we first start with the sign of cos in the second quadrant.
Okay, thank you.
Okay. Okay, so we go to question 2 now. So saying 3 and 4, you guys can do those. Write down the values of the following, leaving your answers in terms of surds where possible. 1, cos 7 pi over 6. The first thing is, if I don't know the value of 7 pi over 6, I don't know if it's bigger than 360 or not. So what I'll do is I'll convert this guy to degrees, which are easy to deal with. So you cancel there, here 1, there 3. So we get 210. Well, 210 is actually less than 360. So we are dealing with cos 210 in degrees form. So what is the value of cos 210? Now 210 is not a special angle. Maybe its reference angle will be a special angle. So let's look at the quadrant where 210 falls. 210 lies in the third quadrant. And to look for a reference angle in the third quadrant, what do? You look for theta by subtracting from x, we subtract 180. So what we'll do is, from 210, we'll subtract 180 and get 30 degrees. Now, because cos is negative in the third quadrant, this guy is going to be the same as negative cos 30. But cos 30 is √3 over 2. So we have found the value of cos 7 pi over 6. So reference angles play a very critical role. That's the reason why I decided to spend my time here. It's of great use. Let's try to sine 9 pi over 4. Nine pi over 4. This guy is bigger than 360. That's 2 point something pi. That we multiply by 180 over pi. Yes. Okay, so 9 pi over 4 multiplied by 180 over pi. So the pi gets cancelled. 2 here, 2, and 2 there, 9. 9 by 9, we get 8, 10 over 2. This guy, we get 405. Now 405 is bigger than 360, so we subtract from 405, we subtract 360. So we have 5, 4, so we'll get 45. So this angle 45, this 45 is telling us that actually 9 pi over 4 falls in the first quadrant. So when you subtract 360, until you are in between 0 and 360, the very angle that you get between 0 and 360, whatever that angle falls is where the bigger angle where you're subtracting 60 from falls. So they share the same properties, though these are coterminal angles. So it means that looking for this, we just need to get sine 45. Very, very correct. Same compression factor. So sine 45 degrees is equal to what? Root 2 over 2. Some like it this way. It's the same because if you rationalize this way, you get that way. Being professional is to rationalize. Okay. Okay, let's do the last one here, maybe. We do cos negative 5 pi over 3. Hello.
Yeah.
Yes.
I have a question, sir, on the when breaking the regions to degrees. What if I was to, instead of where there's pi there, I put, let me say I say 9 times where there's pi, I put 180. I say 9 times 180 divided by 4. It's also giving me 45. So I was asking, would I be penalized if I go this way?
It's actually the same thing that we're doing. There's no penalty for doing what is correct. Okay. So what if it's negative? Remember, we said if it's negative, we add 360 until it becomes positive. So we have negative 5. We multiply by 180 and divide by 3. 3 here, 3 there, 6. So 60 by 5, we get negative 300. So negative 300 plus 360, we'll get 60. So this guy is actually the same as cos 60. Cos 60 is half. You guys must also know that these two angles, remember, we said f of x is said to be even if it has this property. It will be even. and f of x is said to be odd if it has this property. Now we're saying sine of negative x is the same as negative sine x. So sine is an odd function. Cos of negative x is the same as cos x. So cos is an even function. So we have these are very, very important. So that you don't need to worry about that negative when you see it in cos, because it will make it positive. You're not worried about it. We go to question 3. So you guys are going to answer 4, 5, and 6. And same thing. Question 3. Prove the following identities. To prove all the identities in mathematics, especially this course, the one that you need to know is that sine squared x plus cos squared x is equal to 1. If you know this identity, then you know a lot, because you understand that from this, if you solve for cos squared x, you just take sine the other side. If you decided to solve for sine squared x, you just take cos the other side. That's a master one. That one needs to know. And from there, the other things will come later. But maybe you need 1 or 2. So I give you some more. That was 1. 2, you also need to know the compound. If I say a plus or minus b for sine, what I will get is sine a cos b plus or minus sine b cos a. So that if you have cos a plus or minus b, what you get is cos a cos b minus or plus sine a sine b. Notice the change of sign for cos. If it was plus, it would be minus. If it was minus, it would be plus. For sine, if it was plus, it would be plus. If it was minus, it would be minus. And then the fourth one, we are now dealing with tan. Tan a plus b. Remember, tan is the same as sine over cos. But how we expand these guys, we say sine a cos b plus cos a sine b over cos a cos b minus sine a sine b. This guy can also be written in the form where you decide to leave everything in terms of sine and cos by dividing every entry by cos A cos B. We divide every piece of this by cos A cos B, both in the numerator and the denominator, over cos A cos B. Then you will notice that this one is giving us tan. These two, they will cancel. These will cancel. These will cancel. This one will give us tan. These will cancel. And these guys will give us tan. These guys will give us tan. So what will remain with is, for the first one, it is tan A, plus the second one, it is tan B, over 1 minus tan A, tan B. So this is the identity for tan A plus B. So that if it was tan A minus B, the only thing you do is to change the sign there, so that you also come down and have a plus. So the sign of the numerator is the one that you have in between there. The sign of the denominator is the opposite sign of what you have. So from this, you get to know cot, you get to know sec, you get to know cosec. Because you guys must realize that actually what we call sec is actually 1 over cos. What we call cosec is actually 1 over sec. I mean 1 over sine. And what we call cot in terms of sine and cos is cos over sine. And cot in terms of tan is 1 over tan. So some of us we already know this, but to some this is a new thing. So please take care. Okay, we can now go to 3A. So 3-1. 3-1. So you say cos squared theta plus 3 sine squared theta is equal to 3 minus 2 cos squared theta. You look for the proof. So we get the left-hand side, the most complicated. If you look on the right, we have cos, meaning that from the left, we must change whatever sign we have using the first identity. So sine is written in this form, 1 minus cos squared x. So we have 1 minus cos squared x. But this guy is just cos squared x plus 3 times 1, you get 3 minus 3 cos squared x. And this is just the 3 minus cos squared x minus 3. That is like 1 minus 3, which is 2 cos squared theta, I mean. So like x. So it's theta, it's theta. So if you look at what you have, 3 minus 2 cos theta is the right-hand side, meaning that we are done with the proof. Becomes so nice. You can also do the second one, where you say cosec theta minus sine theta is equal to cos theta and cot theta. Is there a question from Tricia? Okay. So you say cosec theta, again here you get the left-hand side, standard looks forgetted. So you say x is just 1 over sine minus sin theta over 1. Get the common denominator of sin theta. So theta itself get 1 by minus 1, get 1 minus 1 is sin theta again, theta by the sin of sin square theta. But 1 minus sin square theta is just the same as cos square theta from the identity number 1. So that divided by sin theta. Looking at the of bracket proving, we can write cos as cos multiplied by cos and you get that sine. So the cos remains cos. The cos over sine is cos. We have that there. So that we're doing 4 x over cos x minus sin x is equal to cos x plus sin x. And that cos x, this one here, cos 2x is the same as cos x plus x. So we can expand it in the form of x minus sin x, sin x, meaning it's cos square x minus sin square x, which is what? Just cos x squared cos square x minus sin square x, or cos x minus sin x. Now you guys know that if you have x squared minus 4, you get the difference of 2 squares because it's the same as x squared minus 2 and minus 2 squared. Then say x minus 2 and x 2. If you had x squared minus 9, you call the difference of 2 squares because it is y minus that. So you say x minus 3, x plus 2. Now we have the same setup here. We have the same setup here. So I say, we might have the difference of squares, so we write as cos minus sin x multiplied by cos x plus sin x. And then we divide by cos x minus x. So you can see that this guy, so we remain with cos x plus sin x is the right hand side. Yes. So that if you are doing sin x over 1 minus cos x is equal to cos x x. And here, you also doing sin x plus x, which is sin x cos x plus sin x. Okay, so that is 2 sin x cos x. So that you take the left hand side, divide 2 sin x cos x and divide by 1 minus cos 2 x minus 1 is cos x. It's cos x and sin x. So that what we have now is what we put need sign in the which is what we have done here into sign. This is 2 sin x cos x 1 minus cos times 1 minus sin squared minus sin x. And here we have this time 2 times 1 minus 1 and then we get positive here becomes 2 sin squared times then 2 cos x divide that as sin x so we get cos x over sin x equals but guys otherwise we do this 7 power 6 3 power 6 so we go to 4 1 equal to and t cos x is equal to 3 and find the smallest possible values. So 20 is the smallest possible value of x. Instead of solving this, you solve a counting of equations. The number here is p or number 4. So you solve the equal equation of 4. So you solve p. So you from the system, it will be 4 sin x. 1 equals 4 to 3 over x. And p is p, meaning that 4 which is p sin x is equal to 4 to 3 over x. So 5 over 4 over x equals 4 to 3 sin x. If you divide by 4, divide by 4, you get x to 3. And then you go back and get p. So you say p is equal to 4 over sine 30 over sine 30 half. We are doing 4 divided by half, which is 4 multiplied by 2 over 1, which is 8. Then you would have you don't know how to determine them. You can be using either the triangle or the table method. So if I give you the triangle, normally for 30 and 60 we use a triangle. This guy here is 60. This guy here is 60. This guy there is 60. And these sides are equal. If you decide to cut in between there, you form 90. So if I draw that part, I draw the right hand side, I'll remain with 1 here because it was 2. 2 there, 30 here where it was 60, and 60 here, 9. The first thing we'll be finding the opposite sides. So since we have 2, you square 2, subtract the square of 1, you get 4 minus 1, which is equal to 3. Its square root will give us a side. Then from SOHCAHTOA, we know that sine 30 is opposite, which is 1 over hypotenuse 2. We know that cos 30 is adjacent, which is root 3 over hypotenuse, which is 2. We know that tan 30 is opposite, which is 1 over adjacent, which is root 3. We also know that sin 60 opposite, which is root 3 over hypotenuse, cos 60 adjacent over hypotenuse, tan 60 opposite, root 3 over adjacent 1, so just root 3. So for 30 and 60, Then for 45, we use this guy here with equal sides. So if you add them and square root, you get the square root of 2. This is 45. That's 45. That is 90. So same ratios, you notice that sign 45 is coming out to be opposite, which is 1 over root 2, cos 45 opposite over root 2, and tan 45 1 over 1. That's how you usually detect the 30, 45, 60 angles from the triangles. Okay, so we go to 2. 2, given that tan x is equal to negative 3 over 4, and that x is an obtuse angle, find the exact value of sec 2x and tan 2x. Now sec 2x is the same as 1 over cos 2x. But cos 2x, you guys notice that it was cos squared x minus sin squared x. I can as well write cos squared x as cos x squared minus sin x squared. And we are given tan, and we are told x is an obtuse. So being an obtuse, it means that it's bigger than 90. So it falls in the second quadrant. So you come in the second quadrant and draw your triangle there, where this guy is x. And then tan is opposite, which is 3 over 4. Then Pythagoras theorem get us side. So 4 squared plus 3 squared is equal to 25. The square root will be 5. Plus 1 plus root of. For that same triangle, we are able to use x. Remember, cos is adjacent over hypotenuse, so it will be negative 4 over 5. Sin x is going to be opposite over hypotenuse, which is 3 over 5. So we go back and say, okay, so sec 2x is actually 1 over whatever this was x, you put negative 4 over 5, and have it squared, minus sin x, you put 3 over, and have it squared. So that you get 1 over 16 over 25 minus 9 over 25. So it says 1 over 16 minus 9, you get 7 over 25. So this is the same as 25 over 7. So I found the value of sec 2x. To find the value of tan 2x, remember, we said this is just the same as tan x plus x. But tan x plus tan x, tan x plus x is just tan x plus tan x over 1 minus tan x tan x. If you want for the top one, you can say 2 tan x plus the same, and that one tan x. Sometimes they can be very funny and ask you to prove that tan 2x is actually this. So that's how you get proof that. So now we have known that tan x is 2 tan x over 1 minus squared x. But we're already given in the question, we are given what tan x is. Ours is just to substitute negative 3 over 4 over 1 minus negative 3 over 4 squared. This is negative 3 over 2 over, because I'm canceling here, don't get confused, over 1 minus, don't make a sign, the negatives cancel because that negative is actually squared. So it will disappear by the square, and so you get negative 3 over 2, everything over 16, 16 minus 9. So we have negative 3 over 2 multiplied by 16 over 7. So that this guy here 1, that guy there 8. So we get negative 24 over 7 as the value of tan 2x. Do we have questions?
So
Sir, how
Hello.
did you find the 5 on the triangle there?
The 5 here.
Yes.
Pythagoras theorem says that if I have this guy here, and I have this side as A, that side as B, that side as C, then C squared is the same as A squared plus B squared. So if I want n side, depending on the side given, in that case we are given A and B. So we squared A, we squared B, and to get C, we have to get the square root so that it remains C.
Oh, all right. Thank you, sir.
Let's go to part 3. Part 3, we are dealing with sine A is equal to 3/5 and cos B is equal to 5/13, where A is an obtuse angle and B is an acute angle. So we start from A. Remember, A being obtuse, it means that it falls in the second quadrant, where we draw the angle like that. This guy here is A. And his sine is given as 3/5, exactly what we found in the other question. Oh, I have to skip a page here. Okay, let me not write on the other page. Okay, so it's okay. So we said this is 3/5, where 3 was this side and 5 there. So this guy will be -4. You can still find them by calculating. So what we have is, okay, so for A, we have found A. What about B? B is an acute angle. So meaning that B is in the first quadrant. So you can draw B here. That is 90. This is B. And that is cos. Cos is adjacent over hypotenuse. So calculate for the missing side. So we say 13 squared is equal to 5 squared. Let's call the missing side A. So it will be plus A squared. So if we do 13 squared minus 5 squared, it will give us A squared. So the square root will give us A, which is the square root of 169 minus 25, which is root 144, which is 12. So that guy is 12. Then now we can go to the question. Question says, find sine A plus B. We know that this is just sine A plus B plus cos A sine B. But sine A is known, is 3/5. Cos B is known, 5/13, plus cos A. So we got the triangle where A is and get the value of cos. Cos is adjacent over hypotenuse from A. In sine B, we got the triangle where there is B and get sine. Sine is opposite over hypotenuse. This guy is giving us, we decide not to cancel, we have 15/13 by 5, that is 65. In fact, I can put negative directly, since we know that that is -4 by 12, which is 48/65. So we get -13/65. That is for sine. We can also do for cos A minus B, which is equal to cos A cos B plus sine cos A B is 5/13 and B 15. So negative 20 over 65 plus 8.
Sign would be negative 60.
Okay. So now this is 16. 16 outside. Therefore, because when the other is the one A, B, the same as switching this number, what is that? A plus B over and A and B, the same as minus and A and B over and A and B. One and A back to A and then that is 4, which is 3. So negative 4. Multiplied by tan A, which is 4. Right. Divided by tan A, which is negative 4. That is 1 minus 1 plus 30. So 20 is over there. Will give us this thing will give us the multiplication sign. You see common denominator is 20, so it will go up over 45 to get negative 15 plus 5, therefore 38. So the question is down again. We have 20 minus 20 plus 36, which is 56. So we'll get 56 over 20 multiplied by 20 over negative over positive. What is the day again? Yeah, 33. The 20 will cancel, so we get 56 over 33. Not so sure if it can be reduced. You can reduce, you can reduce. I think this 3 can go in 56. I don't think so. So that would be a 55 version of it. Unless we have questions.
Excuse me, sir. I'm kind of confused on the numbers which they are like 3 and the negative 4, the 13.
I can't get you.
How are you getting the values on the sketch? The sketch that you made, the 3 and the negative 4 and the 13 and the 5.
Look, initially we are given this, is it? We're given that as sign A. So that means that it will belong in the second quadrant. So if it is A, then we're saying that sign belongs to be first one. I will say on that side. If I get this in the quadrant here, so I will get the value down.
I understand what you're saying.
Can we use also the fourth quadrant?
But no, because that the B is an atom.
Okay.
Yes. Let me go to question 5. So next one is solution. 6, 5.
Okay, we'll do question.
The question 1 is select this to the other side. You get negative 2 minus 2 is actually equal to k, implying that k is equal to 4. So what we have is y equal to 2 minus 4 and x at that point. So have that value of k. Find the value of k. We have found the value of k and the greatest value of y. So what is the greatest value of y? So when you think, so there are ways here. You may think that the greatest value of y is when sin x is 0. But now it's also possible that the greatest value of y is when sin x is negative 1. In fact, that is the greatest value. So when you have negative 1 there, it will multiply the negative 4 to make it positive, and then add and get 6. That will be the biggest value of y. So where this sign did not appear. The only thing we got to know is that sin itself is actually 1. So we use its actual value. It's not here. It's just replaced. Okay, so which angle here gives us sin x is equal to negative 1? Well, there are so many angles. If this sign x, we get sin 270 negative 1. So we know that at that point sin negative 1 means sin 270, which is 2 minus 4. Sin 270 is negative 1. That is plus 4 is 6. So this is the greatest value of y. y equals 6. The other one, the sign runs from 1, 0, negative 1. We have one state of sign. You understand that that is 1, this is negative 1. Sign go up, come down, later you get back. So the least you can go is negative 1, the highest is 1. But if sign is 1, you know, when for which is negative 2. If sign is 0, you have 2 minus 4, but which is 2 and which is 2. If sign is negative, that's the negative value of y. And then, so that's how we get the y is equal to 6. And now that we have reached this far, you can questions and take a breath and explain to us what we can